There are millions of compounds that fall under the branch of organic chemistry. To easily identify these compounds and their structure, scientists have assigned names to these compounds. The system of assigning a name to a compound is known as nomenclature. There are two systems for naming organic compounds: the common or trivial system and the IUPAC system. Let's look at the trivial system. The trivial names are given on the basis of the source and certain properties of organic compounds. For example, citric acid is named so as it is found in citrus fruits. Formic acid is named so as it is obtained from the destructive distillation of formica, which means red ants in Latin. This system was commonly used before 1892, and it did not follow any standardized rules. Moreover, more than one common name is given for certain compounds. To remember the common names given at random for large number of compounds that are discovered day to day is difficult. Hence, the need to develop a systematized method for naming organic compounds is found to be indispensable. Thus, in 1947, the IUPAC, that is the International Union of Pure and Applied Chemistry system of naming compounds, was first developed. The IUPAC system of nomenclature is a set of logical rules devised and used by chemists in which the name of a compound correlates to its molecular structure, thus making it intuitive for a person to deduce the structure from the name. However, common names are preferred for the IUPAC names, which are lengthy or complicated. Let's understand how IUPAC names are assigned to various compounds. The IUPAC name of an organic compound basically consists of three parts: the root word, the suffix, and the prefix. A root word indicates the length of the continuous selected carbon chain. A chain which consists of up to 4 carbon atoms is assigned special word roots based on the common names of alkanes. Thus, the word root for 1 carbon atom is met, 2 carbon atoms is eth, 3 carbon atoms is prop, and 4 carbon atoms is but. A chain that consists of more than 4 carbon atoms is assigned a root word derived from the names of Greek numerals. Thus, the root word for 5 carbon atoms is pent, 6 carbon atoms is hex, 7 carbon atoms is hept, 8 carbon atoms is oct, 9 carbon atoms is non, and 10 carbon atoms is dec. Now let's look at the suffix. There are 2 types of suffixes: primary and secondary suffix. A primary suffix indicates the nature of the carbon chain that is saturated or unsaturated, and the secondary suffix indicates the functional group present in the compound. A primary suffix is added to the end of the root word. It indicates if a compound is saturated or unsaturated, that is, whether the compound consists of a single or multiple bonds. The three primary suffixes are ane for alkane, ene for alkene, and ine for alkyne. A secondary suffix indicates the nature of the functional group present in a compound. Thus, the three components can be combined to form part of the compound name. For example, the root word eth, primary suffix ane, and secondary suffix all together form the IUPAC name ethanol. A root word eth, primary suffix ane, and secondary suffix oic acid together forms the IUPAC name ethanoic acid. If a functional group is present, then E of the primary suffix is replaced by the secondary suffix. Now let's look at the final component, the prefix. There are two types of prefixes: primary prefix and secondary prefix. A primary prefix is used to differentiate acyclic and cyclic compounds. However, the rules for using these are slightly different. For example, in cyclic compounds, the prefix cyclo is added before the root word. In the IUPAC system, some groups are not considered as functional groups. They are treated as substituent groups. In such cases, the substituent acts as the secondary prefix. Some secondary prefixes and their substituent groups are fluoro for fluorine, chloro for chlorine, bromo for bromine, iodo for iodine respectively. However, in acyclic compounds, the primary prefix is not used. So, if the prefix cyclo is not used, it indicates that the compound is acyclic, as in propane. We know that hydrocarbons are organic compounds that contain only carbon and hydrogen. The hydrocarbons, which consist of carbon-carbon single bonds, are said to be saturated and are called alkanes. The general formula for alkanes is CnH2n plus 2, where N indicates the number of carbon atoms. We know that there are two systems for naming organic compounds: the common or trivial system and the IUPAC system. The names of the first four members of alkanes are based on the trivial names. They are methane, ethane, propane, and butane. The IUPAC name of an alkane basically consists of two parts: the root word and the suffix. A root word indicates the length of the continuous selected carbon chain. A chain which consists of up to 4 carbon atoms is assigned special root words from their trivial names. Thus, the root word for 1 carbon atom is meth, 2 carbon atoms is eth, 3 carbon atoms is prop, and 4 carbon atoms is bute. A chain that consists of more than 4 carbon atoms is assigned a root word derived from the names of Greek numerals. Thus, the word root for 5 carbon atoms is pent, 6 carbon atoms is hex, 7 carbon atoms is hept, 8 carbon atoms is oct. 9 carbon atoms is non, and 10 carbon atoms is dec. A suffix indicates the nature of the carbon chain. As the carbon chain is saturated, suffix "ane" is used. For example, a compound that has 2 carbon atoms in the chain will have the root word eth and the suffix "ane". Thus, its IUPAC name will be ethane. Similarly, the IUPAC name of an alkane having 4 carbon atoms is thus but plus ane, butane. Alkanes can be straight chain alkanes or branched chain alkanes. Let's look at the IUPAC names of certain straight chain homologues of alkane series. The IUPAC name of an alkane having 1 carbon atom is methane. The IUPAC name of an alkane having 2 carbon atoms is ethane. The IUPAC name of an alkane having 3 carbon atoms is propane. The IUPAC name of an alkane having 4 carbon atoms is butane. The IUPAC name of an alkane having 5 carbon atoms is pentane, and so on, as shown here. Let's look at the trivial and IUPAC names of the branched chain alkanes. Small chains of carbon atoms attached at 1 or more carbon atoms of the parent chain is said to be a branched chain. These small chains of carbon atoms are called alkyl groups. Let us briefly study about the alkyl groups. The group which consists of 1 hydrogen atom less than an alkane is called an alkyl group. For example, if 1 hydrogen atom is removed from methane, that is CH4, we get the alkyl group CH3. An alkyl group is named by replacing the ane in the name with YL. Thus, the name of alkyl group of methane will be methyl. At times, abbreviations are used for certain alkyl groups. For example, methyl is abbreviated as Me, ethyl is abbreviated as Et, ET, propyl is abbreviated as PR, and butyl is abbreviated as But. Alkyl groups are called as primary, secondary, or tertiary based on whether 1, 2, or 3 other carbon atoms are directly attached to the carbon atom in the chain. Alkyl groups derived from the saturated hydrocarbons having minimum 3 or more carbon atoms can have the following possible branched structures. For example, propyl and butyl groups can have the following structures. The trivial names given for these structures are isopropyl, secondary butyl, and tertiary butyl, as the carbon atom is attached to other 2 and 3 carbon atoms respectively. Now let us see how in the trivial system, the various straight chain and branched chain alkanes, such as butane and pentane, are differentiated. If all the carbon atoms form a continuous straight chain, that is, without branching, then the prefix N is given to the name of the alkane. For example, for the structure shown here, which consists of a continuous chain of 5 carbon atoms, the name given is N-pentane. If the carbon atom next to the terminal carbon having a methyl group as a branch is attached to a continuous carbon chain, then a prefix iso is given to the name of the alkane. For example, for the structure shown here, which consists of a branched chain and is a 5-carbon system, the name given is isopentane. If the carbon atom next to terminal carbon has 2 methyl groups as branches, is attached to a continuous carbon chain, and then a prefix neo is given to the name of alkane. For example, for the structure shown here, which consists of 2 branched chains and is a 5-carbon system, the name given is neopentane. The corresponding alkyl groups are named as N-alkyl, isoalkyl, neoalkyl respectively. Examples of N-alkyl, isoalkyl, and neoalkyl are shown here. They are N-pentyl, isopentyl, and neopentyl respectively. Now let us look at the IUPAC rules to name the branched chain alkanes. Rule 1. Select the longest carbon chain in the molecule. In this compound, the longest chain consists of 9 carbon atoms. Hence, it is also called as parent chain or root chain. Selecting the longest chain as in second case is not correct because the parent chain consists of only 8 carbon atoms. Rule 2. Number the parent chain that has branches. The numbering of the chain is done in such a way that the branched carbon atoms get the lowest possible number. If we number the chain from left to right, then the branches are located at carbon 2 and 6. And if we number the chain from right to left, then the branches are located at carbon 4 and 8. As per the rule 2, the numbering should be done from left to right. Rule 3. Name the branched chain alkane. The name of the alkyl group attached to the carbon atom as a branch, that is, a substituent is given the appropriate prefix to the name of the parent alkane, and the position of the alkyl group on the parent chain is indicated by writing the appropriate number. If more than one alkyl substituent is present, then the names of alkyl groups are listed in alphabetical order. For example, in this compound, the alkyl groups methyl and ethyl are fixed to the alkane nonane in the alphabetical order, and positions of the substituents are 2 and 6. Hence, the name of the compound is 6-ethyl 2-methyl nonane. The numbers are separated from the alkyl group name by using a hyphen. Rule 4. Name the identical alkyl groups at different positions of the carbon chain using the prefixes di, tri, tetra, etc. If more than one identical alkyl group is present on the parent carbon chain, at different positions, prefixes such as di for 2 identical alkyl groups, tri for 3 identical alkyl groups, tetra for 4 identical alkyl groups, etc., are used with the alkyl group. For example, while naming the following compound that has 2 methyl substituents at 2 and 4 positions, the prefix di is used. Hence, the name of the compound is 2,4-dimethylpentane. Similarly, prefix tri is used while naming the following compound. Hence, the name of this compound is 2,2,4-trimethylpentane. The position numbers of the substituents are separated by comma. Note that the prefixes di, tri, etc. are not considered when deciding the alphabetical order of the alkyl groups. In the following compound, the ethyl group name is written first as per alphabetical order, ignoring the prefix di used for methyl group. Rule 5. Numbering different alkyl groups at equivalent positions. If two substituents are present on equivalent positions, then the lower number is assigned to the group that appears first in the alphabetical listing. For example, in case 1, the ethyl group is present on carbon 3, which is assigned a lower number than its position at 6 in case 2. Hence, the correct name for the compound would be 3-ethyl-6-methyl-octane. Rule number 6. Numbering the complex substituent. If the substituent, that is, the alkyl branch on the parent chain, is complex, then the carbon atom of the branch attached to the parent chain is given the position 1 while numbering as shown. The name of this alkyl branch is placed in the parenthesis while naming the compound. The use of prefixes such as iso, secondary, tertiary for naming the substituents, that is the alkyl groups, is allowed in the IUPAC nomenclature, but such alkyl groups should not be further substituted. Iso and neo are considered, but secondary and tertiary are not considered to be part of the fundamental name of alkyl groups during writing the names in an alphabetical order. The parent chain, which contains more number of side chains, is selected. The chain highlighted in red has 3 side chains attached to it. If we select the other chain, as shown, as the parent chain, it will have only 2 side chains attached. Hence, case 1 is the correct way to select the chain. The chain should be numbered from the end which is closer to the alkyl groups. Here, the alkyl groups are attached to carbon 3 and 5. Here, the substituents are attached to carbon 6 and 8. So, it is far from the substituent. Hence, it is a wrong way of numbering. Then, the substituent groups are numbered. As there are 4 carbon atoms present, the alkyl group is butyl. The ethyl group is attached to the second carbon atom. Hence, the name of the substituent is 2-ethyl-butyl. The substituent 2-ethyl-butyl is attached to the 5th carbon atom of the parent chain. Hence, it is 5-2-ethyl-butyl. Here, 2-ethyl-butyl is written in parentheses. The parent chain consists of 10 carbon atoms. Hence, it is decane. 2 methyl groups are attached to the 3rd carbon atom. Hence, their name will be 3,3-dimethyl. the name of the compound will be 5,2-ethyl-butyl 3,3-dimethyl-decane. Now let's look at the nomenclature for the cyclic compounds, also known as cycloalkanes. Cycloalkanes are saturated compounds containing a ring of carbon atoms. They are named by adding the prefix cyclo to the corresponding straight chain alkane. For example, in a ring consisting of 5 carbon atoms, the prefix cyclo is added to pentane. Hence, the name of the compound is cyclopentane. If different alkyl groups are present in a cyclic compound, then the names are written in alphabetical order. For example, in the following compound, as per the alphabetical order, methyl group comes first, followed by propyl. Hence, the name of the compound is 1-methyl-3-propyl cyclohexane. This cyclic compound consists of 6 carbon atoms in a ring. Hence it is cyclohexane. The compound is numbered from right to left. The ethyl group is attached to the 3rd position of the cyclohexane, and 2 methyl groups are attached at position 1. Hence, the name of the compound would be 3-ethyl-1,1-dimethyl cyclohexane. If the compound is numbered from left to right, then 2 methyl groups are attached at 3rd position. This means that the more branching is at the 3rd carbon atom, and the name of the compound would be 1-ethyl-3,3-dimethyl cyclohexane. This is incorrect.